So we're going to look at distance with parallel lines again. Again, we're talking about parallel lines. Now we're going to talk about the distance between them, or the distance between a parallel line and a particular point. Okay. So this would have been one of the things that we actually did like a construction on, remember? So if you want to go back and do constructions, you can take and do the construction that we did. Put your little pointer on this and draw your happy face and make a line. Obviously, we're looking for the shortest distance between this point and this line, which is going to be that perpendicular segment. That's why you can do your construction. But obviously, most of you won't carry around your compass or whatever, so you won't have that. So, we will look at other ways of doing this. But postulate 3-6 is our perpendicular postulate. And again, I don't know if you really need to write this one down, but if given a line and a point, as I just drew above here, here's my line, there's my point. We could get more specific and say a point not on the line. There is exactly one line through the point that's perpendicular to the line. So basically what they're saying is there's no possible way that I can draw multiple lines like this and for them to be perpendicular. It has to be that one specific line. And again, like I said, you could use constructions, but probably what we're going to try to do is, if we can figure out what this point is right here, we're going to probably use the distance formula. Now, if you take the time to graph this and figure out where the actual point of intersection is, you can actually do something that's a little easier than the distance formula. And we'll show you that in just a second. Well, what was the distance formula between any random 2 points? Remember? Remember this? What did we do on the inside? We subtracted, right? That's why it didn't matter which one comes first. And then we're going to add them together. So basically what we're trying to do, if I know this point up here and this point down here, no matter where my line and point are, I can stick them into that distance formula and I can figure it out. If it's on a coordinate plane and we do this, I would actually go through the process of maybe setting up right triangles. Meaning that if I know where something is definitely straight, I can set up where my hypothesis would be and everything like this. So if I knew where this point was, and I have this straight line here and a straight line here, as long as it's on something that I can actually see, meaning on my black lines in my coordinate plane, I can actually count them. And then if I have a right triangle, which I do, I could use what? And that is? Exactly right. So this is one thing that, it's basically the exact same thing as the distance formula, it's just kind of a little easier. And what do you have to remember? That A and B are the sides of my right triangle, and C is the hypotenuse. So it is a little simpler process, I guess you could say. Remember now, if I'm going to do this, if I know where my dot is and I know where my line is, I need this dashed line that's perpendicular. So what's true about my slopes? What's true about slopes that are perpendicular? They're opposite reciprocal. So again, if I have my original slope and I want the perpendicular slope, if this one's 3/4, my perpendicular slope is negative 4/3. So I could just take and, as long as I could figure out what my negative slope was, in this case it would have been 0 and no slope, so it would have been easy because it was a straight line. When we get to the coordinate plane, we'll show you ones where you're going to actually have to figure it out. But if I can do this, then I can draw this other line, and I can see if I end up right on an intersection. That will help us a lot because then I have two distinct points that I can put into my distance formula. If they don't land on one of my crosshairs, meaning my black lines on my coordinate planes like this, then I might have to do a system of equations. This is where the math comes into play. You remember systems of equations? This is where you can either do substitution or elimination. So you would take the equations that you are using and you would do one of those two methods to find where the point of intersection is. So this is going to get us your second point of the point of intersection. And we'll show you that in one of the examples. Now, what you'll have to do in this process right here is you're going to have to figure out or find the second equation to use. And that's where some people get confused. So when we're trying to find that second equation, and once we do find it, then you're going to use one parallel line and the perpendicular line for this process. Now this might be a little confusing what I'm saying right here, but it'll make more sense when we get to an example. So the most important thing is that we want to make sure on our coordinate plane that we hit actual spots, meaning that we hit the crosshairs. So we're looking for something like right there. If it's in between, that's when you'll have to do this process of the systems of equations. And that's where it's just a little bit more math. Okay? So again, this is kind of hard to explain without looking at a specific example. What they want you to understand in some of these examples here is that when you start looking at these things, got enough room there? I figured out I got to get a little closer to this. All they're really trying to show you here is that they want you to realize the distance or the shortest distance between any 2 points is a direct line. So that's what they're showing in this. They're looking at a peak of a roof. So this beam right here, the shortest distance between this point A at the top and my main beam is drawing a perpendicular segment. So that's what we're looking to do in a lot of these examples. So here's my first example. So it says line S contains points 0, 0, and negative 5, 5. Find the distance between line S and point 1, 5, which is V out here in the middle. So here's my line that they got. And they want us to find the distance right here between this point and this blue line. So we're looking for something right here. So if I saw this right here, the first thing that I'm going to do is try to figure out what is the slope of this blue line. How do I find my slope? Well, I can either use my 2 points and stick it into my slope formula, which is the difference of the y's over the difference of the x's. Or, if it's already drawn for us, it's way easier to just what? Count, right? So what's my slope? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it's -1. So what's my perpendicular slope? If this is -1 for my blue line, what's the perpendicular slope of that line? +1, right? So, from the point that they're asking you to find, I'm going to use my new slope, and I'm going to apply that slope. So I go up 1, over 1, or down 1, right 1, and I would continue to do that. And hopefully, if it's right, my point would be right here, and then looks like right there, right? Remember, if my slope is 1 over 1, I can make it anything that I want as long as it's a number over itself. So I can make it 2 over 2 or 5 over 5 or whatever. That's still 1. And so if you noticed, as I did my slope, and this will be a horrible line, but go with me here. That would be the line that I would come up with if I would have used a ruler. And now I can easily find my distance because this point right here is on a crosshairs, right? And this point right here, they already gave me. So basically what I'm trying to say is I could do my distance formula because I have this point right here, and I can easily find what this point is right here. What's that point? -2, 2, right? Okay, so I could use -2, 2 in my distance formula with this point right here, 1, 5, and I can stick it into this distance formula. Or, if you want to try to set up a right triangle, basically, I want this diagonal line to be my hypotenuse. So, if I would go through and try to figure out how I could draw a right triangle, if I go from this point right here across and this point right here down, notice this triangle right here that I just made, that's my right triangle, right? So this to me is a little easier because now if I come back, can I find out what the distance from this point right here to that point right there is? That's what? 1, 2, 3. It doesn't matter if it's positive or negative. And what's the distance from here to here? Another 3. So this would be my a squared. My other 3 would be my b squared. And I'm looking for my c squared. So to me, if I can do this right here, this is way easier than trying to do the distance formula. It's pretty much the exact same process. It's just way quicker. So what's 3 squared plus 3 squared? 9 plus 9 is 18. So C would be what? The square root of 18. And then I could punch that into my calculator. But that would be the distance between this point and that point. That make sense? I realize it's Friday and we haven't been here for a while, but holy cow, we are way zoned out. So let's see if we got it right. So they went through the process of finding the distance formula, but either way, we got the square root of 18. Okay? So, you want to go through another one? Yeah. This one right here looks like it's going to work out just fine too, but we can show you that. So, first things first, what's my slope of my blue line? So again, if you want to go from the 2 points that they gave you, or you just have to find where it hits exactly on a crosshairs again. So even if I went way up here to here, I see that my slope is what? 1, right? Or 1 over 1. So what's my negative slope? Or sorry, my perpendicular slope? Then it would be -1. So if I come from here and do -1, I'd go down 1 to the right one or up 1 to the left one. And again, if I do that, my line would end up going, oh, I missed it on right there. Right? Everybody agree with that? And so then the place that people have a problem with trying to make your right triangle is, how do I make it? Well, it doesn't matter where I make it. I can make it right here. I can make it anywhere that I want. I just need a right angle. And preferably, I want this to always be my hypotenuse, which is the perpendicular side. So if I had this, I would have had 2 squared plus 2 squared this time. So if I did the math there, what's that? What's 2 squared plus 2 squared? 8. So I'd have the square root of 8. So it looks like it should be B, right? So again, notice how fast we can do that if we can make a right triangle. It's a lot faster than figuring out the points and sticking it into the distance. Okay? Now, the last thing I want to show you is this. Here's the one that gets a little bit more complicated. So it says, find the distance between the parallel lines A and B whose equations are. Okay, so this is where we're trying to find the distance between those 2 points. Now they introduce a word in the chapter, if you would go through this, that says equidistant. What does equidistant mean to you? Yeah, they're equal distance, right? So it makes sense that if I had parallel lines, no matter where they were, straight up and down, straight or horizontal, at a slant, no matter what, every single spot on those 2 parallel lines should be equidistant, right? There's no place in between those 2 lines that should be greater or less than any other place. Agreed? Okay, so what they're basically saying is, I need to try to find some distance, but I want to find some spot that's going to be easy. So again, if I looked at these 2 equations, they better have the same slope because they already told me that they're parallel to each other. So if I look at that, it's true. My slopes are 2. So what is the perpendicular slope of these? -1/2, right? So I want you to think about this before I show you. My perpendicular slope that I'm going to use is what Con said, -1/2. Where would be the easiest place for me to figure this out from on one of my lines that are provided? Where it crosses, right? So I'm either going to pick for A, probably this point right here, or I could pick right here. It doesn't really matter. I just need to be able to know what that point is. Okay? Maybe you come over to this line and you pick this point or this point. It doesn't really matter where it is. But that point that you pick, and I think they do this point right here, so we'll go along with them. Now you can pick that point and you apply this perpendicular slope that you figured out. So from this point right here, where would you go? Down 1 to the right 2, right? Or up 1 and to the left 2. Now this is why this one makes it a little harder, right? Because when I connect my lines, notice what happens. This spot right here isn't on a crosshairs. So can I realistically tell what that point is? Not really, right? So what I'm going to do then is, this is where my system of equations comes into play. So I'm going to use substitution or elimination, but I have to first figure out what's the equation of the red line in this example. What's my equation of this line? Well, what would this point right here represent on my particular line? The y-intercept. And what was my slope? -1/2. So my equation in y equals mx plus b would be what? Y equals -1/2 x minus 1, right? Because this is my y-intercept. So, as they'll show you here, went too far, my fault. So here's my equation that they came up with. This is the equation of that line that we were trying to find our point of intersection for. So if you go back to this real quick, and this is where this one is a little hard. This is my equation right here that we're talking about. Y equals 2x plus 3, right? Plus 3, and then my slope was 2x. So I'm using this line, which is A, and my perpendicular red line because I want to find this intersection point. If I was looking for a point on this line, then I would have to use y equals 2x minus 1. Make sense? I know you're just saying, yeah, because you want me to shut up, but you're going to have to do this on the quiz and the test, so make sure you pay attention here. So these are my two lines. They did substitution. You can do elimination. It does not matter what it is. Does everybody understand what I'm saying between substitution and elimination? Substitution, I'm putting it into the equation. Elimination, I'm lining them up and down. And I have to then have the same number, same coefficient in front of one of my variables. Totally up to you. I wouldn't do substitution in this one just because of the 1/2. But you can totally do however you want. And they did substitution. So they basically took this and put it in for the y. And now they're just going to solve. So if you go through the process of solving, you end up with x equals negative 8/5. This is why you have to do this process, because you want that point of intersection to be an exact answer. The one where we drew our perpendicular line on there, we would have just had to guesstimate, and there's no way anybody's probably going to guesstimate negative 8/5. That's why you have to do this process. Okay? So then, again, once you have your x, you're going to take that x and stick it back into one of your equations to find your y. And once I have my y, then I have my second point, and then I would go back and use my distance formula. I would definitely use the distance formula on this one because going back and trying to make that right triangle back on our original line that we tried to make, this one right here. If I would try to draw my right angle here, or my right triangle, again, I would have to guesstimate what my distance would have been here, and I could have figured out maybe this one a little easier, but I'm still going to have to guess where it's hitting. So that's where, once we get these answers, I would stick them into the distance formula, and we would still get our same answer. So the second ones, or this, anytime that you are given two parallel lines, it is a little bit more math, but I believe on the quiz and the test, I found parallel lines that even when you drew that perpendicular line, they hit crosshairs. So you didn't necessarily have to do this process of systems of equations. It worked out perfect for you. So you can thank me for that. Okay? I think you do have to do this process in the assignment today, at least once. So you go through the math part. So, does that make sense what I'm trying to say there to everybody? Okay? All right. And I believe that's it, unless you want to see another one of those guys. So, if you want to see another one, we can go through an example of that one too. But otherwise, here's your assignment. So with this then, on Monday, there will be a quiz, and I'll tell you what's going to be on that quiz in just a second.